All right, it's 8:05, so I'm going to start. Good morning. Welcome to day 35. 1 week from today is the halfway point for the class. Not that that's a big thing, but just so you have some kind of an idea. Now, after I sent out the first um, email to you this morning, I went online and tried to look for some really good resources. All right, for other things that you could go over here, and I've got this list. Now, I'm not going to take the time to go over each one of these because for you watching me, going ahead and clicking URLs is kind of silly. The only two that I do want to mention are this one, and I'd sent this one to you before, but this one here, this is a YouTube presentation. It's 30 minutes long, and it just basically is an introduction to object-oriented programming. It's right, I got it here already. And they talk about what are considered to be the four pillars of object-oriented programming. We're going to talk about that in a minute. Those being encapsulation, abstraction, inheritance, and polymorphism. All right, so we're going to talk about those today. The other thing that you may want to take a look at, and I push this kind of stuff at you, if this is your first class with me, then you may or may not have heard about it before, but W3 Schools, the World Wide Web Consortium, w3schools.com, has their own C# tutorial, and in there they've also got a big OOP or object-oriented programming tutorial, and I think they're both good. All right. As far as getting started, some of the other things that I put in here, just again, an FYI, I'm not going to go over them, but you'll notice that a couple of these are right from Microsoft itself. All right. So they're things that you may want to take a look at. All right. Okay. So again, welcome to day 35. I'm going to talk about a couple of these articles that I did email to you this morning, or I attached to the email, and we're not going to spend much time on there, 5 or 10 minutes or whatever, and then we're going to jump right into chapter 12. This is going to be kind of a different way of looking at things. For lack of better words, you've been warned. All right, this isn't going to probably be as intuitive as I think a lot of the other stuff we've done this semester has been. All right, anything that we're about to do, this is a very blanket statement, but it pretty much holds true that anything, virtually anything that we are about to do with object-oriented programming, you could do without object-oriented programming. All right. So, it's like, okay, fine, I can do it without it. Another thing that we're going to get into shortly along with this is talking about databases. All right. Do you want your stuff to persist? So after you get done doing something, do you want it to still be available to you? And that's where this stuff is going to end up becoming important. All right. So, like I said, we'll talk in just a minute about these articles. This is that YouTube presentation again. Tomorrow will be lab. All right. The test was due yesterday. I know that at least some of you turned it in, and I'm hoping that all of you turned it in. All right. I will take a quick look out there and see later today. I'm going to start grading them sometime this afternoon. I don't know when. I will tell you by Sunday, they will all be graded, if not earlier. All right. And if some of you have turned in either the homework or the written tests or both for chapters 9 through 11, even though they're not due till Sunday, which is good. And I'll try to grade those as well. All right. Please, I've mentioned this before. I'm sorry if I'm sounding like a broken record, but please keep looking at your grade sheet out on Inside Rankin. All right. And if there is something that you have turned in that you don't think I've graded, let me know that right away. All right. So we're going to go over these two articles and then we'll go over chapter 10. All right. Now, are we going to do any actual coding today? We're going to look at the examples that are in the chapter. All right. And I want to go through this very, very, very slowly and deliberately, just because, again, this is a different way of looking at things. So we may end up even getting done early today. I don't know. All right. But what I'm going to send out to you, what you will have sent out to you sometime this weekend, I guarantee it, will be the homework for chapter 12. All right. And probably the way that I'm looking at it right now is next week, Thursday, 1 week from today, which is, I don't know, March 7th or something like that, that'll probably be our next test, and it'll be just on chapter 12. To prepare you for that, the homework for chapter 12 will have 6 problems. We're going to probably do half of them together. All right. Now, I don't know. Nobody has really come back and emailed me on this. And I know, I mean, if I've got X, Y, and Z that I want to get through today, sometimes probably I go over it a little faster than maybe I should. But I will try when we do this, because we'll have Monday, Tuesday, and Wednesday of next week to prepare us for this. So what I'm looking at right now is probably on Monday of next week, we'll go through exercise 12.1 and exercise 12.2. Don't worry about what they mean. All right. We haven't talked about this yet. All right. And I'm going to spend a lot more time on 12.1. I don't think 12.2 is as relevant to where we want to go in here, but we'll see. All right. Then, like I said, we will go through 3 of the 6 problems together. This, as I have been doing all semester, I'll save out to a GitHub repo. But the actual problems that we'll do, and yeah, I've actually, nope, they're not here, but I've got them out here someplace. Nope, those are the articles. But you'll get them either later today or probably tomorrow. You'll get those sent out to you. All right. But when you take the test a week from today, there's 2 problems on it. They both will involve the use of object-oriented programming. Why am I even mentioning that when that's what this is about? Well, I know that on the last set of assignments, and I shouldn't even say the last set, but when we were in chapter 8 and we talked about arrays, I had at least one student who did all of the homework, but they didn't use arrays for any of the problems. Now, the subject of that chapter was arrays, and it even said on the thing, on the homework page, use 1 or more arrays in each one of these examples, and they didn't. Guess what? Every one of their programs worked. But since they didn't use arrays, they only got half credit. So instead of a 50, they got a 25, even though they had 3 working programs. Is that fair? Maybe not. But, like I said, that the same thing is going to apply here. And what I mean by that is that you're going to have to use classes in these. All right. So just kind of for lack of better words, I'll just say get used to them. So let's go over these 2 articles fairly quickly here. The first one, as you can see on your screen, and hopefully you should be able to see my screen, says object-oriented programming concepts, how to go from 0 to 1 with objects. Well, notice what it says here. Manipulating objects and getting the results is the ultimate goal of object-oriented programming. We're going to go through all the, the definitions for all this stuff. So don't worry about that. All right. But just to get you started, think about it this way. All right. You're a human being. I'm a human being. We're all human objects. We come from what's referred to as the class of people. All right. So the goal of object-oriented programming is to work with objects. What are objects? All right. And objects are instances of classes. What are classes? They're blueprints for objects. I've used this analogy before. I'm right now sitting at Rankin. I'm in a conference room, and across the street from where I'm sitting right now, there is a woman who owns a house. Next to that house are several acres of land, I've been told at least, that she owns those. I have no idea. I don't care. But the point is this. Let's assume that there is enough space on that land to put up 100 houses. All right. So a developer comes in and offers her an astronomical amount of money and says, I want to build a neighborhood in here. I want to put up 100 houses. And out of those 100 houses, we have 5 house plans. In other words, they already have an architect who has come in and has 5 different house models in there that they want to use. Some might be 2-story, some might be 1-story ranch, etc. All right. Well, each one of the house plans that are there, those would be basically a class. So there would be 5 classes of houses. All right. Each one of the houses that gets built off of one of those plans would be an object. So when you talk about object-oriented programming, you create classes as blueprints, basically, from which you can create objects, all right, of different types. And those objects can communicate with one another, just like you and I communicate with one another. All right. Let's just take this as we go through here a step further. All right. So again, if we had, let's just say that there was a class that we called human. All right. And in there, for example, there would be a Jeff object. All right. So that's the class, that's the object. So what makes up an object? All right, it's an instance of a class, but what does it have? And it has basically 2 things in it. It has properties and it has methods. All right, what are properties rather? They would be things for me like height, weight. All right, I'll just leave it there. What are methods? They're things like eat, sleep, drink, etc. So classes are blueprints from which we instantiate or create objects. Objects contain properties, which is basically the data, and methods. And all methods methods are functions. They're functions. But since they're inside of an object, we refer to them as methods as opposed to functions. And you'll notice after each one of these, I didn't do it here because my font is too big. Maybe I can do it if I stretch that out. I don't know. But you'll notice that with each one of these, there are parens after it to show that indeed, what do I want to eat? How long do I want to sleep? What do I want to drink? Etc. So all I'm doing right now is giving you the 35,000 foot view. In other words, we're looking at it from an airplane. All right. And this is very general, very generic. Now, notice one of the object-oriented programming languages is C#. You've been using objects the entire semester. And I mentioned this the other day as an example. When you create a button is a button object, meaning it's part of the button class. So all these controls that you've been working with all semester, they're all objects. The form itself is an object. All right. What we're getting to in chapter 12 is how to create your own classes and your own objects based off of those classes. Now, to truly understand the concept of object-oriented programming, these are the 4 concepts that you have to be able to start understanding. All right. And we're going to go over those in just a couple minutes. Okay. And the first 2 are actually very similar to one another. All right. But we'll go over them and you're going to have to at least have some kind of an understanding of them. So here's what this article says. All right. Basically, it says that everything that you come in contact with in your life is an object. I'm looking out the window right now and I can see my car. My car is an object that's made up of door objects, window objects, an engine object, etc. All right. If I created a car class, I could have classes underneath it. So a car class could contain a window class, it could contain an engine class, etc. So classes, as it says, they're like blueprints, and objects are instances of those blueprints. All right. Now, it says here, a class is a user-defined data type. Your own classes are user-defined data types. But you've been working with system-defined data types, a button class, a label class, a text box class, a list box class, radio button class, etc. All right. Now, some of the stuff that they talk about in here, with properties, and they give some stuff a little different than what I said. But these would be the properties. If you used a tree, for example, the name, the age, etc., these would be the behaviors. And really, behaviors are methods. All right. But let's go in and talk right now about these things that are considered to be the 4 hallmarks of object-oriented programming. And I'm going to tell you something. Before I came to Rankin, when I decided I was going to move here, all right, I had an interview at another school, and it was for a Java programming instructor. All right. And I had taught Java before and thought I had a pretty good understanding of the language, etc. And my interview, they were doing all the interviews remotely. All right. And so I had my interview with them. This was actually before I think Zoom was even around. It was a telephone interview. All right. And they basically, almost the entire interview was explain to me each one of the 4 pillars of object-oriented programming. All right. And I was kind of lucky. They couldn't see me and they could hear. I'm sure if I would have gotten online and keyed something in, I had some articles. I worked my way through it. I thought I did a good job. All right. They didn't offer me the job. So maybe I didn't do a good job. I don't know. All right. But let's talk about these 4 things. The first one is called encapsulation. All right. And what they're talking about, they give an example of a pill where they say, for example, if you've ever looked at a lot of pills, they've got like a almost some kind of a tablet, but the actual medicine is inside of there. So what does that have to do with anything? Let's look at it this way. All right. I'm going to give you 2 words. I may have given you these already. I don't know. But there are 2 things in here that you have to understand. And one is the word interface, and one is the word implementation. All right. And I'm going to give you a very simple example, and I've used this before. So if you've seen me do this example before, sorry, you get to see it again. But if I come up here and I bring up a calculator and I want to know the square root of 1,367. All right. I can bring that up, hit that, and now I know it's 36.97, etc. Okay. What I just showed you is the interface. It's what whoever made this calculator, Microsoft or whomever made it, it's what they decided I could see. The actual code that ran between the time I typed in 1,367 and hit the square root key and the answer that came up, however they got this, that's the implementation. All right. So what am I telling you? That as a developer, all right, if you were to go in and let's say that you got a job as a C# developer, let's say that happened. All right. There may very well be a reason and an occasion where you would go in and create classes. All right. Typically, with your classes, what you're going to do is you're going to do what's called expose your methods. So in other words, those methods a lot of times are going to be public as opposed to private like we've been doing really all semester. But your data will almost always be private. So the only way that you can reference this private data is to use these public methods. And you might say, well, that makes sense, or that doesn't make sense. So the interface is what you let the person see. The implementation is what happens behind the scenes or under the hood or whatever you want to call it. So when you work with, all right, when you work with, start to work with these pillars that we're talking about in here right now, and we work with encapsulation, all right, what it is they even say a class is a good example of encapsulation. It says all the data members, the variables, the properties, etc., and the behaviors or methods, all right, are gathered together and closed. All right. So I can go in and use, I have no idea if Microsoft built a calculator class to show me that thing. I don't care. All I know is they show me the interface and I put in my input and I click the button and get the results I want. That's what matters to me. All right. So I'm blind basically to the actual implementation. All I see is the interface. The advantage of that is what if in the future somebody comes up with a way of doing square roots even better than the way that they're done right now. All right, even better. Well, if my interface doesn't change, if my look and feel of this doesn't change, you can change the implementation and I don't even know that it's changed. And it may sound like, okay, that sort of makes sense, or maybe it doesn't. But, all right, what's important about that is the fact that the actual implementation is encapsulated from me. All right. And what they mention in here is they show you this picture. Now, this is not the best picture in the world. All right. I do want you to understand methods can be private or public. Data can be private or public. We're going to look at some stuff today, and I'm going to show you a couple ways of doing things, and they're almost going to seem like they're opposites of each other. They're not. All right. But as it says here, by using encapsulation, data can be restricted from the usage of the outside world. And the act of encapsulating is also known as information hiding. I don't need to know how Microsoft's calculator figures out the square root. So as it says, it exposes the necessary things, that's the interface, and it hides the important things, that's the implementation. All right. So the second one that's in here is referred to as abstraction. And it's very similar to encapsulation. All right. And they give an example. There's nothing wrong with their example, but let's just talk about it this way. All right. Okay. I got ready for work this morning. Eventually, I went out to my car. I started my car up. It's in the driveway. It's not backed in. So I started my car up. I put it in reverse. All right. I slowly went back because the guy who lives across the street from me parks his car where it's very hard for me to get out of my driveway, but he does it. All right. So the point is, when I put the car in reverse, I don't know physically what happened to the car. Those details have been abstracted from me. All I know is the interface that I have that's got a button that I push to start my car. And I've got it's not a stick, but it's kind of a stick on the floor. And I just had to go and put it into reverse. So I don't have to worry about the details. They've been abstracted from me. And that's the way that we live our lives. So there's a real high tie-in between encapsulation and abstraction. In fact, abstraction here talks about interface and implementation. And I just did. All right. So there's not like a whole heck of a lot more that I have to mention on that. All right. The next one, inheritance. This is the third one here. All right. And what they're saying is inheritance in software is in many ways like genetic inheritance. And again, I've given this example before, so sorry if I'm being redundant. But typically, if you have, let's say that you have a man with a big nose who marries a woman with a big nose and they have a baby, there's probably a pretty good chance that baby will have a big nose. All right. And I'm not criticizing or anything. I'm just saying that's kind of genetics. So that child either lives their life with a big nose or gets a nose job. It's not like they can take their nose off if they don't like it and put another one on. But with software inheritance, you can do that. All right. What do I mean? Well, this right here is an inheritance hierarchy. It's 3 levels deep. The top level is level 0, then there's level 1, then there's level 2. And it could go down and literally possibly have hundreds of levels. All right. So electronic devices, what we would put up in here is everything that's common to any kind of an electronic device. As an example, one thing we might put in there is like has a plug. In other words, it's able to be plugged into a wall. All right. And then you've got children of electronic devices, and they keep it simple with a computer and a washing machine. All right. Now, possibly you come down here and you've got some other kind of computer, and guess what? They don't even, they totally run on battery or solar or something else. They don't even have a plug. That means they get the ability to use one, but they don't have to. Not only that, they can do what's called override something. So if something is defined up here and we don't like it here, we can basically reconfigure it. It is the idea that I mentioned before, as if you had a child with a big nose who could somehow take that nose off and put another nose on. All right. Now, electronic devices is the parent class for computers and washing machine. Computers is both the child class, or also known as the derived class. So this is known as a parent class or a base class. So electronic devices is a parent or a base class. Computers is a child or a derived class of electronic devices. It's also a parent or base class for mini computers and supercomputers. As it says, inheritance is a very powerful feature of object-oriented programming. And there's different types of inheritance. We're not going to go over those right now. The one we're basically going to deal with in this class is a single inheritance type. All right, which means you only have one parent, for lack of better words. All right. Then finally, the last thing that's in there is polymorphism. And polymorphism means, it's a Greek term that means many forms. All right. So what I just talked about in here, where I said if you didn't like something, you could change it. All right, that's called overriding it. If I have something in here, and I've given you this example before, I just want to quickly show it to you here. So if I come in here and do something like this, int x equal 3, int y equals 7, int sum equals add 2, and I put in here x and y. Whoops. And I'm going to make this a little smaller, otherwise I'd run out of room. All right. And now I come in here and also, maybe it's later on in my program, I say double A equals 18.67, double B equal 45.21, double sum equals add 2 A and B. All right, now later on in my program, I write this. I write int, add private, int, add 2. All right, and I can put in here number 1 and number 2. All right, and all this is going to say is return n1 plus n2. Okay, oops, don't need that. And that's it. All right. Then I also write, I'm just going to put it off so you can see it here. I also write private double add 2. All right. And I've got in here, I'm going to have to make this even smaller. All right. So I've got private double add 2. In fact, this would have to say int n1 and int n2. All right. So this I could put in here now double n1 and double n2. All right. And I can just copy this. I don't want to do that. Let's just do it like this. So return n1 plus n2. Now, I'm not wasting your time here. I want you to understand this. This is almost the same as this. What's the difference? This returns an int and has 2 ints passed into it. This returns a double and has 2 doubles passed into it. So add 2 is what is referred to as an overloaded method. It's the same method, except what are called the signatures in here are different. Here, it's expecting 2 ints, and here, it's expecting 2 doubles. Now, the program is smart enough to know that if we pass it 2 integers, it better call this one here. And if we pass it 2 doubles, it better call this one here. This knowing, so to speak, which one to call based on what's referred to here as this method's signature, that is polymorphism. All right. And that's what they're talking about in here. They go through dynamic binding and late binding. All right. And some of that I can draw a I can draw a parallel or a comparison, all right, to arrays in C# and arrays in JavaScript. Now, those of you who haven't taken the JavaScript class yet, don't worry that if this doesn't make sense, but I do want you to see this. If I'm working in JavaScript, I can do this. I can say let X equal array, like that. And then I can start putting stuff in it, or I can fill it. All right, so basically I can come in here and I can say, Jeff, 72, 225, true. So what am I trying to show you here? That if I'm working in a language like JavaScript, in the array here, I can put different data types in there. You cannot do that in C#. You can do this in JavaScript. In fact, later, I can even change these if I want. In JavaScript, you can do something like this. You can say let age equal 33. And then later in your program, you can say age equals hello. You won't get an error for doing that. But you'll notice that unlike what we do in C#, we're using the word let here. we're not using int or string or whatever. And that's because in JavaScript, this stuff is late binded, which means that as the program is running, all right, you can change data types and what is put in there. In C#, I couldn't do this. I would make a string array of first names. I would make maybe an integer array of heights, maybe another integer array of weights, and another and a Boolean array of marital status. And the reason for that is in C#, the stuff is early binded, not late binded. All right. So when something is dynamically binded, that means that it can be basically set up while the program's running. If something is early binded, and they don't really get into that here, all right, then at compile time, when you're compiling the program, you have to know what it is you're trying to do. All right, yeah, yes, it's taking a little longer, but I'm hoping this is going to be worth it. So data can be hidden from the outside world using encapsulation, also known as information hiding. All right, code can be reused. That's one of the biggest advantages with inheritance. Again, I've given examples like this before. Let's suppose that Enterprise Rent-A-Car hired me and said they wanted to redo the way that they rent cars. So I wrote a brand new car service for them. And now a hotel comes up to me and says, you know, ours is kind of similar. We're not renting cars, we're renting out rooms. Could you modify that? And if I set it up right, yes, I can. All right. All right. Polymorphism allows you to overload things. So in other words, we could use the same function to do different things, the same function name to do different things. We use abstraction for that interface and implementation to, again, encapsulate or hide the implementation from the outside world and just let them see the interface. All right, that's it for that article. Let's quickly go over the other one. All right, and there's going to be a lot of similarity in here, so I'm not going to spend a lot of time on it. All right, they mention in this article, we will go over object-oriented programming as a whole without relying on a particular language. So this is not specific to C#. All right, just so you know that. So again, you know, what is object-oriented programming? One of the reasons I like this article, explain OOP like I'm 5. So they wanted to keep it simple. It says object-oriented is a combination of two terms. Object, which they say is an entity that exists in the real world, and oriented, which means interested in a particular type of thing or entity. So their general definition here is that it's a programming pattern that's built around objects, okay? And they go through an example in here. That's okay. They talk about a printer, but I don't think you'd really get anything out of that. All right? So how OOP became popular. Well, the only thing we're talking about in here is in 2002, Microsoft introduced a brand new object-oriented programming language named C#, meaning it's 22 years old. In my opinion, for whatever my opinion is or is not worth, I've always considered C# to be Microsoft's answer to the Java programming language, not JavaScript, but Java. All right. Next, they show the picture, and these are the things we started talking about at the beginning here. All right. Notice, let me make this bigger, that if you talk about a class, as they say, it's a blueprint to be used for an object, and it will hold attributes and methods. Each instance of a class is known as an object. These methods are the behaviors, so what an object can do. These attributes represent the state of an object. All right, now I lied to you before because my weight really isn't 225. It's more than that. I wish it was 225 right now, but it's closer to 250. All right. So the point is, right now, my state is my age, my height, my weight, etc. Some of the things in my state have not changed since I've been born, such as my first name, my last name, my gender. Some things change on a fairly, I don't know, fairly often, such as my weight. It's yo-yoed over my life. Some things change over time naturally, like my height. All right. So the building blocks again to do this are classes, objects, methods, and attributes. So this is their definition. The reason that I went over the other one first, and now I'm going over this one, the other one did a better job. The other article, I thought, did a better job talking about what are considered the pillars of object-oriented programming, those being encapsulation, abstraction, inheritance, and polymorphism. This one does a better job of explaining what classes, objects, methods, and attributes are. All right, so classes are either user defined or somebody else did it, but even if the user is Microsoft, all right, again, they're a blueprint for objects. Objects are instances of a class. Methods are the functions defined inside of a class that describe the behavior or what an object can do. And attributes represent the state of an object at any time. And it is important that an object always maintains a consistent state at all times. All right. Okay, so again, here's the pillars: encapsulation, abstraction, inheritance, and polymorphism. All right. Functions manipulate the information and keep it safe. No direct access is granted to those functions. In other words, they're hidden. They're encapsulated from you. And they use a real life example here. They say, think about a human resources department at a company. It hides data about employees. Even when I go out to inside Rankin, my view is much different than your view. There's certain things I can see, but those are all things about me. All right. I can't see, for example, Mr. Gudmiston, who teaches at the St. Louis campus. I can't look at any of his information, not only because it's not my business, but because that stuff has been hidden or encapsulated from me. By encapsulating data as it says, you make the information of your system safer and more reliable. It's more reliable because it's more secure. All right. Then we've got abstraction. As it says, you try to take things that are complex and break them down into more simple types of pieces. So it says there, abstraction is used to handle complexity by allowing the user only to see relevant and useful information. Their car one is not that different from the one I gave you. All right. Inheritance, which we talked about earlier, as it says, it allows a child or a derived class to inherit features from a parent or base class. All right. So they mention here you use inheritance in object-oriented programming to classify the objects in your programs based on common characteristics. Now, as we start in here for chapter 12 and for chapter 13, we're only going to be working with one class at a time. When we get into chapter 14, we'll bring in inheritance. And then you will learn, all right, then you will learn how these different classes can work together and how inheritance works and how it's set up. Now, they give an example of an employee object. So if I created an object of type employee, I might say all employees have a first name, they have a last name, they have a department they work for, they have some kind of a salary or pay that they have, etc. But then underneath that, if I said, okay, I've got programmers And maybe programmers are salaried. And then underneath, we've also got another class underneath employee called hourly. All right, and those are the hourly workers. They're not salaried. So we take all the stuff that's common to all employees and we put them as high up in the hierarchy as possible. And then as we work our way down, we get more and more specific. All right. And then finally, with polymorphism, as it says here, this is the power of two different objects to reply to a form. If that confuses you, let's look quickly at one last example of that. All right, I'm going to get rid of this. And I'm going to say, let's assume that we made a class and we call this class animal. All right. And then underneath that, we had a dog, we had a cat, and we had a bird. I'm just keeping it simple. All right. And then for our animal class, one of the things that we put in there, okay, is we put in a method in there that was called speak. All right. Now, you know this. I'm not being funny or anything else. The way that you would say dog dot, so maybe Fido dot speak would be different than saying Fluffy dot speak, which would be different than Polly dot speak. So what I can do is I can define a generic method up higher in my hierarchy and then override it. So this says woof or rough or whatever. This says meow and this says tweet. And the system is smart enough to know that if I'm working with a dog object, all right, a member of the dog class, that when I say to speak, it'll say bow wow or rough or whatever you say a dog says. And if I'm working with a cat object, all right, it'll say meow or purr or whatever, and a bird will say tweet or whatever. But it's smart enough to know which method, even though they all have the same name, it is smart enough to know which method to call or to utilize based on the type of object that you're working with. And again, that's polymorphism. And what does that give you? So this is on page 10 of this article, and it says it gives you about a half dozen things or so. Code reusability. All right. You don't have to write the same code multiple times. Improved productivity. And that has to do with the other one that we just mentioned, the code reusability. All right. Encapsulation. Again, that's the idea that some stuff is going to be public and some stuff is going to be private. All right. Now, just so you know, this stuff has literally been around for about 55 years. There was a language back in, I think it was about 64 or 65. Might have been a little later, it might have been 68, called Simula. That was really the first object-oriented programming language. So it's not like this is totally brand new. All right, now we'll take a break in a few minutes, but before we do, just two things to mention. All right, we're going to be going over chapter 12 today. So they talk about this whole section, and that's chapters 12, 13, 14, 15, and 16 are all going to be on object-oriented programming. All right, we're going to go over 12 today and spend virtually all next week on 12. Then the next week, we're going to do 13, 14, 15, and 16. You'll have nothing from chapter 13. I don't even think I'm going to give you the written test. We will go over 14 because that's on inheritance. We will go over chapter 15 because that's interfaces. We already talked about an interface versus an implementation. And we'll go over chapter 16 because that shows you how you can build libraries for your classes. All right. My hope is that by next Thursday, we will take our test on chapter 12. Next Friday, then will be a lab day. Then the following week, we're going to go over 13, 14, 15, and 16. And either by the end of that week or the beginning of the next week, we'll take that test, which will almost solely be on a little bit of 14, a little bit of 15, and a little bit of 16, nothing on 13. All right. Then we go into the next section of the book, all right, which we'll start to get ready to work with databases. All right. So when we come into this, this is the chapter that we will, this is the chapter that we will be going over after we take our break in a few minutes. All right. So we will be going over chapter 12, how to create and use classes. I'm not going to read to you. All right. But it says what we're going to do is get all the building blocks for working with classes. At the end of the chapter, the last 10 pages or so, they talk about working with structures and working with records. All right. And record structs. Okay. We will talk about those. All right. That might be a part of your written test. I don't know. What we do at the end of this chapter is we work with a class, then we kind of go back and do almost the same program, but we do it again and we use a record struct. I'm going to do both of those for you on Monday. The reason I'm telling you that is after we do this, you will never be tested other than, again, possibly on your written test. You will get no homework. You will get no hands-on test that will work with records, that will work with structures, or that will work with a record struct. But I want to show it to you so you have at least been exposed to it. All right, but we're going to concentrate much more on the use of classes. And again, I'm telling you that because when we get back from the break, we're going to go over and spend almost the entire period on this. And then just the last few minutes on this. But as I already mentioned, other than if you get asked questions on the written test for chapter 12, there'll be nothing else that you'll need to know for structures, records, and record structs. So when we come back from the break, we'll get an introduction to classes. I'm going to build the example that's in the chapter, and I may or may not do it in the exact order or way they do it in the book. Now, the example they put in here, my hope at least is it'll be fairly straightforward. All right. So let's say that we go through this today and it makes sense to you. You're like, I kind of get this. Then I just want to mention one thing to you, and it goes back to something I talked about earlier, and that is this. Where is it? This thing here that says explore object-oriented programming with classes and objects. This is from Microsoft itself. All right. The reason I'm telling you this is you might want to work your way through this. Just read it. Why? Because they use an example that's very similar to one of the homework problems we're going to have. And that is they create a bank account class where you can go in and make deposits and make withdrawals. I'm not going to spend any time on this because we haven't talked about this stuff in any, really in any significance yet other than the last hour. All right. So it is 9 o'clock. We're going to take a break. We're going to come back at 9:10. And once we come back at 9:10, we're jumping right in here to chapter 12. All right. I'll see you at 9:10. and I will be right back. A little scary. Yeah. All right, it's 9:10, so I'm going to start back up, and I'm going to give you an example. I don't know if this is going to be good or be bad, but I'm just going to show you something here because it goes along with what I talked about with you before. So let me come into here. All right, and I'm going to create a folder, and I'm going to call it first oop. All right, so it's going to be the first one that we're going to do in here. And this, since I am literally doing it off the top of my head, I'm hoping it's going to work the way I want it to work. All right, I'm going to come in here. I'll make it a Windows Forms app. All right, and I'm going to call this people oop. All right, and that's all that's going to be in here. So I'm going to also save it, and I'll put it in the first oop folder. All right, so click create, and there it is. Now, you know this from before, okay? So if I come in here and do this, so let's come in here and oops, I want to widen this out a little bit. Come on. There we go. So if I come in here and do a couple things. All right, so first of all, let me do a file, save all, so I can change the name. So let me do a rename, and I'm going to call this FRM People. P-E-O-P-L-E. Okay, yes. Now, what we have been doing in here, all right, as I change the background color, all right, is we've been doing stuff like this all semester. I want to show you, now I want to show you how it's going to change. All right. So if I come in here and do a view, and let me go back and bring up my toolbox and pin it. There we go. All right. So all semester we've been doing stuff like this. We've typically come in here and we'll put in 3 buttons. All right. There'll be some kind of a calculate button. There'll be some kind of a clear button. There'll be some kind of an exit button. Nothing new there. All right. And then let's keep this relatively simple, but I want to show you a few different kinds of variables in here. So I'm going to come in here and I'm going to make a few labels here. So I'll just bring it way up here and I'm going to make it darker and set my auto size to false. There we go. And we're going to have in here a first name, a last name. Again, like I said, I'm trying to keep this simple. We'll put a salary in here and we'll put in how about department, salary, and marital status. All right, just so I'm able to bring in some of this stuff that we're working with in here. All right, and then I'm going to come in and I'm going to create text boxes for each one of these. All right. Okay, you've seen all this before. There's nothing new here. So let me come in and do this. All right. And I guess I made these bigger, that they should be 20 and they made them 26, it looks like. So let me change that back to 20. All right. And then we come in and we do this to take these and basically center them. And then we take these and we center these. That's just the text that's in there. So, and then we've come in and we lock our interface. So there's nothing new here. All right. And if I come through here, because I'm going to still be able to use this in just a minute, but I come through here. All right. And I make this LBL first name. And I put in here, oops, what did I do? LBL first name. There we go. And we call this first name. And then we've got in here, this will be last name. All right. And then this will be TXT first name. And this will be TXT last name. All right. And then this will be LBL department. This will be TXT department. All right. This will be LBL salary. This will be TXT salary. All right, this will be LBL marital status. And this will be TXT. Whoop, I need to put marital status on there. And I guess I have to make these a little wider for that to work. So let's do that. There we go. Now of course I did that. So let me make that a little bigger again. There we go. All right. And let's see, I got to do our calculate, our clear, and our exit buttons. Oops. All right, let me again lock this. All right, now there's nothing new here. All right, but I'm going to show you that basically what we're about to do is going to be an extension of what we have been doing. And what do I mean by that? Well, let me show you. So what we have been doing, so we come in here, we set our accept button, we make that calculate. We set our cancel button, we make that clear. We set our start position to center screen, and we come in, we're going to enter something into each one of these. So this will be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 for the tab order. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Nothing new there. All right. So another view tab order. Now, what I'm not going to do right now is I'm not going to go in and come in and I'm not going to go in and write exception handling or if statements or anything. Okay. I'm not going to do any of that stuff. All right. And there's, because we've already concentrated on that stuff already. All right. So for our exit, let me just throw this junk in here. There it is. So that's done. Our clear will be our clear form. All right. And that'll be txt first name dot text is equal to nothing. Txt last name dot text is equal to nothing. Txt, what else did we have in here? I don't think I named the last one, so we'll fix that in a minute. Department dot text, that'll be equal to nothing. Txt salary dot text, that'll be equal to nothing, It looks like I didn't rename this last one here. I did not. So we will call that txt marital status. And what I always do here, to make sure I haven't missed anything, looks like I missed a label. So that one I didn't change to LBL last name. Let's check one more time. As far as I can tell now, everything has been renamed. So in here now I can also add my txt marital status dot text equal nothing and txt first name dot focus. All right, that's a review, but that's kind of where we started in this class. So of course I can come in here now, I can run the program. Now there's nothing in the calculate button, you know that, but I can put in my information. Let's say $55,000. All right, and I'll put in here married. All right, I can click clear. That works. I can click cancel. Okay, that works. Okay, and or click exit rather, and that works. Okay, that's all working. Now in calculate, we're not doing anything right now. So let's call get employee info. Again, I am not going to be validating any of this. If this was a quote real program, unquote, I would be, but I'm not validating anything. And there's a reason for that. I'm going to show it to you in just a moment. Okay. All right. So I'm going to come in here and I'm going to say string output str equals nothing. We've done this before. And I'm going to say output str plus equal, and we will use string interpolation here. So name, let's see, txt first name dot text, txt last name dot text. Okay, then a blank line. Then we're adding to that. What else did we have in here? We get rid of that. All right, we had in here, okay, we need department, salary, and marital status. What that is. Don't even want to do that. Yeah, I'll do it like that. That's fine. I thought it wouldn't, I didn't. See, I guess I'll have to do it like that then. Oh. There we go. And finally, the marital status. All right. And do I have a? I didn't, so I'll just use a message box here, message box.show. And we'll put in your output str, and we'll put down persons data. Okay, like I said, not a whole heck of a lot new in here, but we're going to change that in just a moment. So file, save all, come in here, and I'll put in my information. Again, I could put in anything here, and since it's not validating, all right, we'll put true. Okay, so me, Jeff Scott. I didn't put a line break in there, but hopefully you can see that. Everything looks like it worked at least. Let me put a line break right here. Try it one last time. And calculate. Okay, so there's all my information, and it looks to me like everything is right. It's all working. Okay, that's fine. But this is the way we have been doing things. We started like this, then we came in and we started to put in some data validation. I'm not going to put that in right now. All right, but we put in some data validation. For instance, we got to the point where we either used if statements or we did like an is valid data. But for a first name, we want to make sure it wasn't empty. For last name, we'd want to make sure it wasn't empty. for salary, not empty, numeric, and within a certain range. And if this was a Boolean field, we'd want to make sure it was true or false. All right. And hopefully what I just said there made sense to everybody. All right. So let's talk about how we can change this. Okay. I'm going to come in, and you haven't seen this before. So I'm going to come in here and I'm going to right mouse click on the name of my project, people. I'm going to right mouse click and I'm going to choose add. And I'm going to go down almost to the very bottom and I'm going to choose class. All right. And it says, do you want to do a class? Yes, I do. The key thing to realize where we are right now is when you create a class, there's no graphical user interface. I want to say that again. There's no GUI. Everything that you do in here is just code. So I'm going to make this person.cs. Also, and I don't know, I didn't write this stuff. I don't know why they do this, but chances are pretty good you'll never use any of this. And you'll want to change that from internal to public. All right, I'm going to do that again so you can see everything I just did. Typically, when you create your own classes in this class, no pun intended, you won't need any of this. You probably won't even need the using system, but you should change the word internal to the word public. All right. So now what am I going to do? I'm going to come in here, and there's different ways of doing what I'm about to show you. All right. I'm going to come in here and say private string first name. Yeah, I know that it's not a lowercase. Usually with class variables themselves, you do it more like this. So last name, private string, department, private decimal salary, and private bool married. All right. What I'm doing right here is I am declaring class variables. These are variables that belong to the person class. I want to say that again. These are variables that belong to the person class. All right. Now, I'm going to have to go back in just a few minutes and make some changes to the form file. But before we do, I'm going to create another thing in here. Okay. And it's going to be called a constructor. Okay. And all I'm going to put in here for now is just public, and then the name, person, and nothing in there at all. Okay. Just like that. What that is going to do is every time I come in and create a new person object, it'll automatically set their first name to the empty string, their last name to the empty string, their department to the empty string, their salary to 0M, and their married to false. Those will be the default values. What if I don't want that? I can go and remember we just looked at overloading, so I can make another constructor. So this will be constructor number 2. And this one is going to expect that all of this stuff is going to be passed in. So I will say string first name, and I could use the word first name in there, but string last name, string department, and I'll put it over 2 lines here. Decimal, and we won't call it salary. I want to make I'm making the name shorter. Sal and bool, MAR. All right. And then I'm going to say exactly what it's showing here. All right. Now, I expect that very little of what I just did made sense. So I want to go back and explain everything I just did here. I have now come in and I have created a new class. This is my own variable. So every time I create a person object, they will have to have a first name, a last name, a department, a salary, and a marital status. All right. And if I just create a new person by saying something like this, and I just so you see it. So if I come through here and I say person Jeff equals new person like that, if I do that, that's going to call this constructor, which again, as I mentioned, it'll set my first name to the empty string, my last name to the empty string, my department to the empty string, my salary to 0M or 0, and my marital status or married to false. All right. If I use the other constructor, this one, I do it something like this. I would say person. In fact, let's call this Jeff 1. So I'll make another person, Jeff 2, and that'll be equal to a new person. And I'm going to put this over multiple lines here, but I'll say Jeff, Scott, IT, so hopefully, you see the difference between these two. With the first one, this is called a default no arg, because there's no arguments, there's nothing in here. It's called a default no arg constructor. This one is calling the full arg constructor. What's the difference? The no arg has nothing in it. The full arg is filled. All right. Could I make yet another constructor in here? Could I make another one where I passed in just the first name and the last name and left the department blank, the salary blank, and the marital status blank? Yes. As long as what's in these parentheses are different, and there's what, 5? So probably there I don't know how many different derivations there are, but I could make another person with just a first name, a last name, another one with a first name, a last name, and a department, etc. All right. Now, this isn't typically the way I'm going to want to do this in here. All right, what do I mean? Well, I'm going to go back now. So let me save this. All right. Let me save this, and I'm going to write a method in here too. Okay. And I'm going to call this, not in there, I'm sorry. I'm going to write it down here. And I'm going to call it public. I think I need the word override, but I'm not sure. To string. Okay. And I'm going to put in here pretty much what I did in here before this. Like I said, when you do stuff off the top of your head, at least at times you make mistakes, and I'm not trying to, believe me, but this could end up blowing up in my face. I don't think it will, but we'll see. All right, don't worry about those. We'll fix those in just a minute. All right, so what doesn't it like here? Person.toStrings, not all paths return a value. Okay, that's not a problem. So this is going to become first name. This is going to be last name. This is going to be department. No dot text. This is going to be salary. And I'm just manually for now, I'm going to put in here a $sign. Okay. In fact, I think I should be able to just say salary : C. Yeah, it'll take that good. And finally, this will say married. All right. So I've got all that stuff in there. So let's see. It's not returning a value. So we will return output str. Okay, so now what I've done is I created a class. The class has in it 5 private variables. Out of those 5 private variables, all right? Out of those, 3 are strings, 1 is a decimal, 1 is a Boolean. And there's 2 ways that I can create a new person. If I put nothing in there for the person, it'll take all of these and set them to the default values that I mentioned to you. If I take this, it's going to set them to whatever I want them set to. And if you say, I don't get it, you will in a minute. All right. And this hopefully is going to print everything out for us. We'll see if it works. All right. Now I'm going to go back to the form here. And where I had this, I don't get any errors. There's nothing wrong. I'm not using the class in this program right here. I want to say that again. I am not using the class in this program currently. All right. So I'm going to get rid of this. And I'm going to see if I can keep this. Notice it doesn't see it, but I'm going to see if it'll take person dot output string. Okay, it doesn't like that. It says person does not contain a definition for output string. We'll have to fix that in a minute. Let me comment that out for now. All right, so now what I'm going to say is this. All right, if I come in here and say person, I want to create a brand new person. Okay, so I'm going to come in at the top of my program here. We'll do it here in the initialize component. And I'm going to say person Jeff equals new person. All right. Now, if I printed out everything, notice it didn't give me any errors. Person, it grabbed that from this file. It was smart enough that it knew there was a correlation there. All right. So I'm going to create another one, and this is going to say person Mary, and we're going to say equals new person. All right. And for Mary, we're going to fill it in. So Mary Jones, she is in web. She makes $100,000 a year, and she's not married. So you'll notice if you look here, I'm not getting any errors in either one of these. It recognizes with this one, I'm going to have to call this constructor, and it's smart enough to recognize that with this one, it's going to have to call the other constructor right here. All right. Okay, so let's see. Okay. All right, so let's see. Let's see right here with what we've got so far. All right, because I've created those 2 in here. Okay, I'm going to see if I can do both when I calculate in here. I'm not gonna for right now. I'm not going to get the employee information. I'm not going to do that. I'm going to do this. I'm going to say Jeff dot to string. And I thought it would take that, but it didn't. The name Jeff does not exist. Person Jeff. All right, I might have to make this. Shouldn't have to make that public. Let me do it here. I'll do this. I don't know why it's giving me an error there, but it is. All right, so Jeff dot to string, Mary dot to string. All right, and I'm going to see if I can take both of those and put them into message boxes. So Jeff dot to string, Jeff's info. Oh, what the heck? So come on. So Jeff's info. All right. And then we'll do Mary's info down below that. Now, if this works the way I would imagine that it's going to work, for me, for Jeff, it's going to go back to here. And it's going to have name and it'll be blank, department and it'll be blank, salary and it'll be blank, married and it'll be blank. Then when we do it for Mary, it'll say name, Mary Jones, department, web, salary, 100,000, married, false. All right, let's see if indeed that's what happens now. All right, I'm not going to put anything in here. I'm just going to click calculate. So there's me. So notice no name, no department. My salary defaults because I put it in currency to 0.00 and married went to false. Okay, that's good. That's Jeff's info. Now we should have Mary's. And you'll notice that everything is filled up. Good. All right. So that's fine. Jeff, why did you show us this? What the hell are we supposed to get out of this? Well, I'm going to change this now. I'm going to keep this right here where we say, just like we did before, where we said in here, where we said person Jeff equals new person. I'm going to keep that in there. All right. But I'm going to add some stuff now. All right. I'm going to say Jeff dot well, I want to say Jeff dot first name, and it doesn't like that, equal, and I want to say txt first name dot text. Thought I could do that, but it doesn't appear to like that. It's inaccessible. Oh, it's inaccessible due to its, okay. Let's come in here and all these variables that we made private, let's go back and make them public. All right, now I want to see if it recognizes it. There we go. All right, Jeff dot last name equals txt last name dot text. Jeff dot department equals txt department dot text, and Jeff dot salary equals txt salary dot text. Now I can say dot toString because I'm not using interpolation, and we'll make that currency. And now let's come in and say Jeff dot toString. Okay. All right. Okay. It doesn't like this. Why? Txt toString. Go from string to provider. All right. Let's go back with that one. I will use string interpolation. And we want to put that in curly's. Now we can actually go in here with this one. This is probably the way I should have done it, but I'm going to say convert dot to decimal txt salary dot text. And I think I can say :C here. Maybe it doesn't like that. All right, we'll get rid of that. What doesn't it like? Your txt salary.text. Syntax error, comma, expect. Oh. Cannot implicitly convert type string to type decimal. All right, we'll say decimal.parse. All right. I want this to work. I want you to see it. So decimal salary equals. All right, so Jeff.salary, we'll put in here salary. C, it does not need a paren. Not in decimal salary. What did we make salary over here? A decimal. Fine. I'll leave it the way it is. I don't know why that's giving me an error, but it is, and I don't really care. So I'm just going to say here, we'll leave it out. How's that? Just for now. And I might get the same kind of thing here for the married. Let's just leave these out. I just want you to see this. Okay. All right. So I'm going to run this. Now I'm going to put in here, Jeff, Scott, and we'll put in something else. We'll put programming in here. All right. Calculate. Input string was not in the correct format. What doesn't it like? Decimal salary equals decimal.parse. I don't know what it doesn't like in there, but there's something. Probably because I left it blank. All right. So it did print out my name. It printed out my department. All right. Since I had the salary set wrong in the married, it did print out, the defaults for those. Now, why am I showing you this? Because I'm showing you here two different ways that you can input data into class variables. This way is setting it, and it's calling the constructor the full arg constructor with everything in it. So when I'm creating it, I'm passing this and this and this and this and this. All right, because that full arg constructor expects everything to be passed in. All right, now I want to show you something here. We could put it, we could come in ourselves, probably should put a try-catch in, but what if I put in something in here that's non-numeric? So what if I put in here, hello? Notice I'm getting an error already, and the error I'm getting says argument cannot convert from string to decimal. So it's smart enough to catch it here before I've even gone in and tried to do something. All right. The other thing, again, is I can easily start filling this up, and I can fill it up based off of what I put into text boxes. And again, that may not seem like much, but it's pretty darn important. All right. All right. A lot longer than I thought that would be, but let's get into the chapter now. I'll fix that up and put that out there too. So we're going to have an introduction to classes, how classes can be used to structure an app, how to define a class, and how to create objects. I've started to show you some of that. Then the basic skills, how to add a class file to a project. I already showed you that. How to code properties, I showed you that. That was the first name, last name, etc. How to code methods, I showed you that. How to code constructors, I showed you that. How to code static members, I'll put one in a bit. Then what they're going to work with in a lot in chapters 12 through 16 is this example. As it says there, it is a product maintenance application. So we will be introduced to that in this chapter. They will build it using a class. Then they will go back and redo it using structures, records, and record struct. All right. Oops. There we go. All right. I don't want to read a flippant thing from this chapter to you. All right. They mention in here a 3-layered app. All right. So what they're starting to do is they're starting to talk about taking your program, which we have been putting everything in here, everything that we do, our presentation and our logic have all been put in here so far, everything. All right. But now we're bringing in this second layer. Okay. An employee is our business class. We won't bring in the database layer until we get to chapter 18. But in a true 3-layered app like this, you separate your stuff up and you separate it up. So this is basically, for lack of better words, this is your interface. This is what the end user sees. This is going to be the implementation. That's what they don't see. All right. And this is going to allow our stuff to persist. We will be able to take that data that we create and save it. So when we come back later into our program, the data will still be there. All right. That persistence is something we haven't used. Now, again, don't want to read to you, but what they call, again, the presentations, notice it's the interface. All right. The middle layer, that's the implementation. The database we'll get to at a later time. All right. Now they talk about why you use the word business classes. It doesn't really matter. The last thing that's in here, we'll get to this when we get to chapter 16. All right. And that is, what if, I'm playing a game of what if right here, but what if this program that we have right here, this one that you saw, this one, what if we wanted to basically make the equivalent of a copy of this, but instead of it being a graphical user interface program, as it is right now, we wanted to make it a true console program. Could we do that? Sure. We could set up a console program. I'm not going to do it, but we could do it in here. The problem is, all right, right now, okay, if we created another project, it wouldn't be able to access this class that we just put in, this person class. But what you'll learn in chapter 16 is we will come in, and when we come in here, we will right mouse click on our solution, not our project, but on our solution, we'll choose add, and we will say in here, new project, and we'll make a new kind of project in here. And that'll be a class library. And then we will take our employee class, put it in a library, and make it accessible to both the GUI copy of our program and, if we have one, the console copy of our program. That's when they talked before about being able to share. That's one of the biggest ways that you're able to share. All right. So how to define a class. All right. And they mentioned in here properties, methods, and events. Okay, and they talk about constructors. So let's, rather than me reading to you, let's take a look at what they have in here. So this is their definitions. I've already given you the definition of property. I've already given you the definition of method, and I've shown you now two different constructors. All right. So let's take what they have here. All right. And I'm going to grab this, and hopefully I'm going to make this easier for you to understand, not harder, but I'm going to come back to here for now. During the next break, I'm going to try to fix this. So what I'm going to do is basically close this. I'm going to close everything that we have here, everything. And I'm going to make a second project. All right. So I'm going to add, oops, not there, sorry. Yeah. So right mouse click, add, new project. It'll be a Windows Forms project again, but it'll be a new one. And we'll call this product maintenance. Okay. So that'll be the name of our project. And it'll come out and it'll have a form in it. We're not going to do a lick with that form right now. All right. Instead, we're going to come into our new product maintenance that we just put in here, and I put products instead of product. So let me get rid of that S. All right. And I'm going to right mouse click in here. I'm going to choose add. I'm going to go back to class, and I'm going to make a class called products. There it is. As I mentioned, typically I start by removing this and changing this to public. Now, the next thing I'm going to do is I'm going to copy in the entire class that's in your book, except for the beginning and ending stuff here. So all of this. So let me copy it and paste it in. All right. Now, what you'll notice in here, it's going to look different than what we did before. Please don't let that throw you. All right, we're going to go over all of this stuff. When you go in and you create properties, there are multiple different ways of doing it. I want to say that again. When I did this one right here, I'm going to bring that class up from what we just looked at. Our people, This is, wrong file, I'm sorry. This is one way to create class variables, not the only way. All right. Now, why am I telling you that? Because in here, they're doing it yet another way. All right. They are using, when they create these, they are using something special called a getter and a setter. What that's going to do is anytime you tell it you want the code, it'll call the getter and it'll return the code to you. If you call the setter, it will allow you to change the value that's in the code. And the same thing with the description and with the price. Now, I know price is a different kind of variable, but when you call getters, they're called accessors. And what you're saying is, give me that information. It's like you walk into class the first day, I say, what's your name? You say, Bob. All right, that's a getter. I'm getting your first name. What's your last name, Bob? Jones. That's another getter where I'd be getting the last name. All right, I'd say, hey, I've got 3 Bobs in this class. From now on, I'm going to just call you Robert. That is setting your name because I'm changing it. Not permanently, but I'm changing it. All right. Now, we are initializing this to the empty string and this to the empty string. I don't even think we'd have to do that. We probably could set this to 0 as well. All right. Now, this is going to look confusing. Now, right here, this is pretty long, so I'm going to separate this into 2 lines. You could have put it all on 1 line. What this says right here is when I call the get display text message, I want you to show me that code that was set up here. I want followed by a separator. That could be a blank space. That could be a tab. That could be a new line, whatever I want. Then give me the price from right here and put it to string with a currency, then another separator, then give me the description from up there. So we've got 3 class variables. They're all public. 2 are strings. 1 is a decimal. Could we have also done this the same way and come in there and done it more similar to the way I did? The answer is yes. All right. So we now have a product. Every time we create a product, notice there's no constructor in here. All right. So there's a method, but when we did ours before, we had no constructor. So the system puts one in for us that looks like this: public product. And what that's going to do, I guess it did keep products, which I don't like. See if I can change that to product. Okay. What that is going to do is that is going to set code to nothing, description to nothing, and price to 0. So if I printed them out now, that's what I'd get. All right. I don't, if I don't put a constructor in, one like this gets put in for me. I'm going to comment it out just so you can verify that indeed that's the truth. All right. Okay, that means that whenever I create a new product, I will not give it a code. I will not give it a description. I will not give it a price. That means later on in my program, I'm going to have to set those things. Okay. So there's their definition of an object of a class. Like I said, an object is an instance of a class. All right. And a class basically is a blueprint. The process of creating an object from a class is called instancing or instantiation. Encapsulation lets you control data and the operation, what gets exposed through data hiding. And that, again, is between that and abstraction. It's what do you show the user? All right. And that becomes your interface. And what do you not show the user? And that becomes your implementation. All right. How to create objects from a class. Again, that's instantiation. There are different ways of doing this. Some of these ways of doing it, you have to have a certain version of C# loaded. I've got 8. So this says here C# 9.0 and later. So that's not going to work for me. This says C# 9.0 and later. So that's not going to work for me. And I'm not going to go back and remove the version I have and put in a later version just so I can put that in. All right. But what I am going to do is I'm going to copy all this right there. All right. So I'm copying all of that information that you see right there. And now I'm going to jump back. I'm going to do a file, save all. All right. I've got, I think you'd agree, there's nothing in here. All right. And I'm going to go and view my code. Again, this is me. I just remove that stuff. All right. And in here, I'm going to see if it'll take that. All right. That's the wrong one. Try that again. All right. So in here, I'm going to try to copy everything that's right here. So copy, I didn't do copy. So. And notice it all worked. Now I'm going to put this over multiple lines. The editor did that. Okay. But I just made a new product. It's called product 1. Then the product 1's code will be C#. Product 1's description will be Murox C#. And the product's price will be $59.50. Also, I should be able to say product 1 dot get display text. All right. Now, I'm going to take that and I'm going to put it into a message box. All right, so what doesn't it like here? I didn't tell it what my separator is going to be. Okay, and it'll be a tab. Okay. All right. Not very impressive, but let's run it and see if it works. Oh, got to run the other one, of course. It's me, so of course I forgot to set my startup project. And looky there. Okay. C sharp 5950 Murox C sharp. Okay, that's it. There is no interface yet. Let's change that to a \n and see if we can put those over multiple lines. It might need an R before it, I don't know. So let's see. Oops. So there it is, C sharp 5950 Murox C sharp. Now, believe it or not, that was pretty darn important what we just did, because what we did was we showed that you can come in and create a brand new class and then come into your program, instantiate. That's what this is doing right here. That is instantiating or creating a new instance of the class. All right, if we did this, I want you to see this, and hopefully what I'm doing is it's going to start making maybe a little more sense to you. Right now, I'm going to call this before info, and I'm going to call this after info. All right, here we created a product, but we didn't put anything in it. So it should all be empty. Let's see if indeed that's the case. There it is. And since we did format this, that's why it's showing me the $sign 0.00. And there it is after it's been populated. All right. So I'm trying to follow now kind of what they're doing in the book and going over it with you as we do this. If we were using a later version, we could also do it like this. All right, so there's, again, as always, there are multiple ways here of doing the same thing. Notice here, again, I'm not trying to read, but I do want you to see this. When you create an object, when it's instantiated, a constructor is executed. Even though we didn't have a constructor in there, the system created one for us, as I mentioned. So if we were to come in here, we could undo this. All right, and I'm going to make another one as well. Now I'll get an error because you can't have two constructors with both with nothing in the parens. So I'm going to say right here, rather, I'm going to say string C for code, string D for description, and decimal P for price. All right, and then I'm going to bring those in. Now, if I want to have them have the same names, so if I want this to be called code and I want this to be called etc., we can do that. Then typically you put the word this dot code, this dot description, and this dot price. But I'm going to do it like this. I'm going to say code equals C, description equal D, price equal P. So now we've added another constructor. So again, as mentioned, this is a no arg constructor, meaning that it is the default constructor, meaning that nothing is passed inside of here. And this one is, and this is just my words, you're not going to see this in a lot of books, but I call this a full arg constructor. I've heard of no arg before. I've never seen in a book full arg. All right. So why am I even showing you this? I'm going to save this. All right. And I'm going to come in now into here and into here, and I'm going to create a second product. So this will be product 2, sorry, product 2 equals new product. And notice when I put this in, and it says, hey, you've got 2 of these. The one you're using now has got nothing in it, but if you change to the other one, it expects a string, and a decimal. So let's put those in. All right, so this will be the code. So we'll call this ASP.NET. It's another book by them. All right, and for the description, I'm going to put this on multiple lines just so you can read it. And it'll be Murox ASP.NET programming. And we're going to say that that is $77.99. Okay. Now we should have a second product in there. So let's see if we can print out that product's information. But it'll be product 2. And we'll even put in here product 2. All right. So first we get our empty product. Then we get our product after we added everything. Then we get our other product. All right. Again, what I'm trying to do here is to, for lack of better words, kind of map what they're doing in the book. All right. With what we're doing. Now, here's an important thing. Like an array, a class is a reference type. So you get the address passed in if you pass a class variable, the whole thing, if you pass the class in or the object into a method or function and you change it, it's a permanent change. All right. So how to add a class file to a class? Guess what? We did this. We right mouse clicked on the name of our project. We chose add. We chose new item. All right. You can either choose new item or you can go down at the bottom. If you remember, there was class. So again, what I'm saying is we can either do it like this. So if I wanted to add another class here, I could choose add, go to new item, and this there it's actually expecting its class. All right. Or we can actually choose class here. Either one of those ways will work. All right. I always just do the right mouse click. I choose add and I go down to the bottom and choose class. You don't even have to add the .cs if you don't want to. It'll be put in there because it's automatically a .cs file. All right. How to code properties? Well, again, good, bad, indifferent, it doesn't matter. There's a lot of different ways that you can create properties. I have shown you 2 of them. In fact, one of the ones, the first one I showed you, isn't even shown in these examples. But it worked. We have been doing this now. All right. This says, if I ask for it, give me the getter. If I want it. So here, if it appears on the on the right-hand side of an equal sign, I'm going to get it. If it appears on the left-hand side of an equal sign, I'm going to set it. All right. So properties, as it says, can be used to get and set. Gets are typically called accessors. Sets, they call it a set accessor. I was always taught it's a mutator. Now, if you put in the word get without the word set, which is legal, if you put in the word get without the word set, it's read only. You can only get it. Not done very often, but if you put in the word set without the word get, it is write only. So you can make a property that's read only, or you can make a property that's write only. Not only that, what you're going to see in just a bit is we can come into here and we can actually do some of the stuff we've learned already. If statements, try catch, etc. We can validate, and we can validate either, when we get the object. So for instance, what if there was no code? What do we want? All right, what if we didn't set a code? You're going to see all that in here in just a moment. All right. So there's different ways of coding methods. All right. What I want you to understand, and I want it to make sense, this right here and this right here are the same exact things. Here, what we're doing is we're surrounding the name of our method, get display text. We're surrounding it with curly braces. This is more considered to be the old school type of way of doing it. Here, we're putting in what's called the lambda operator. It's an equal sign followed by a greater than sign. And just so you know, this could have all been put on one line if we wanted to. They didn't because it was too hard to fit it on the book's page here. But this is called an expression body. So rather than using curly braces, you use the lambda operator. All right. All right. Let's look at the constructors, and then we'll take another break. As it says, by default, C# assigns default values. That is the special constructor. And I showed it to you. I showed it to you both with values and without values. So if you've got an empty no-R constructor, this is what gets set. Any numbers get set to 0. Any Booleans get set to false. If you've got a char, maybe you had like a middle initial, it gets set to null. Yeah, you can pass an object to an object. You can create objects that contain other objects, etc. That's null. And the date will be January 1st of the year 1 at midnight. So if you don't, so if you call one of these constructors like this, all right? And notice when you do that, I want to go back to that because I'm trying to be consistent here and go show you everything. This is instantiating a new object. Product is the type of object we want to create. Product 1 is the name of that object. All right. New means that we're instantiating. And again, we say the type. Since we have nothing in the parens, either it's going to come in here and look for a no-R constructor, or if you don't have one, it'll make one for you. Now, I'm going to say one more thing, and that is with this second example here, if you make a second constructor like we did, where you bring in the code, the description, and the price, if you do that and you still want the user to be able to have a no-R constructor, then you must key that in. So if I remove this and try to run the program again, I get errors. And the error that I get, let me run it again. It says there is no argument given that responds to the required parameter. C it's looking for a code. It doesn't recognize that there is this one. So I have to provide it. I have to provide a no-R constructor if I'm going to overload the constructor like I did right here. That's what I'm trying to get across to you. All right. And again, I'm not reading everything that's in here, but I'm trying to hit the high points with you. Let's see. Okay, good. That's about where I thought we'd get. So let's go back. How to code static members. All right. And what's kind of cool, you've already been using these. You just don't realize you've been using these. But if you remember, I'm going to get rid of this right away, but I want to show you this. All right. If we come in here and do this, if I come in and say random, rand equals new random. We've done this before. All right. Now it should make more sense. I'm saying from the random call, from the random class, create a new class variable called rand and call its default constructor. All right. So we have been using this, is what I'm telling you. All right. You have been using this. All right. But the reason that that's important is now we can come in here and we can say rand.next. It may give me an error here. Don't worry if it does. All right. Rand.next, paren. All right. And like I said, don't worry that's giving me an error. It's because of where I have it located in the program. But the point is this. If I take this stuff and I put this into my program here, all right, I'm not going to get any errors. But what I want you to understand is this, okay? And that is we're calling rand.next. We don't have to say random. But if you remember earlier, when we were working with that previous program in here, the people one, when I came in here and started doing stuff with it, I had to say Jeff.first name, Jeff.last name, Jeff.department. And why did I have to say the name of the class? Because these were not static. Typically, not always, but typically, if you're going to come in and create static variables, if you are going to come in and create static variables, all right, what that means is you don't need to create an instance of the class in order to be able to use them. You can just start using them. All right. So fine, dandy. Why am I going to want to do that? How am I going to want to do that, etc. Quite often when you use static members, they're for things like counters. All right. So if you make a static member, every time I create a new person, if I wanted a count of how many people I had, I could add one to that counter. All right. Okay. Now that, again, that may not have made a whole boatload of sense. And if it didn't, don't worry about it. You can read this yourselves. What we're going to end up making pretty soon is our own validator class. I don't know if you agree with this or not, but for lack of better words, and sorry if I'm offending anybody, but it's a pain in the ass to keep writing these programs and have to keep copying in is present, is decimal, is within range, etc. So what we can do is we can take all those methods and put them into their own class, put them into what's called a class library, and then bring them into any program we're working on that we want to. That's what we're moving towards. All right. So it is 10:25. Let's come back at 10:35. We're going to pick it up on page 390 here on the product maintenance app. I'll see you in 10 minutes. I've got to refresh my water, so I'll be right back. All right, it is 10:35, so I'm going to continue on. Most of the rest of this chapter then talks about this product maintenance app. All right, as it says, we're going to present a product maintenance app that maintains a simple file of products. All right, as it says, it uses 3 user-defined classes in addition to 2 form classes. And if you say, I don't know what that means, you're going to look at it in just a minute. All right, let's take a look at how it works. Okay, there's going to be 2 forms in here. So this is our list of products. Okay, you're going to have to just take my word for it because some of this stuff, it's going to work with a file and we haven't talked about files yet. But this is going to persist. This is going to be our list of products. When you click the Add Product button, it's going to bring this up right here. So you can go in and add a brand new product. All right, so in other words, if we put in the stuff that's here and click Save, then what's going to happen here is we're going to have another product down here. It'll say here ASP MVC. It'll say here 6150. And it'll say here Murox ASP.NET MVC. All right. If you come here and you click the delete button and nothing is highlighted, nothing will happen. If you highlight one of the options and you click the delete button, it'll come up and say, are you sure you want to delete this? And it'll actually even show you the code. All right. Or I guess it's the description. Finally, if you come in here and you click cancel, nothing will happen. And if you come in here and say no, nothing will happen. So you can read this yourselves, but it is a product maintenance app. And what it is allowing us to do, just so you know, because this is a word you're going to hear a lot when we get to databases. And that is, this app is allowing us without a database, we're not using a database yet, but it is allowing us to use CRUD operations. And CRUD is create, read, update, and delete. All right. The create here is our add. That's the new product form. So that's create. Read is this. So that's read. All right. I don't even know if we've got an update in this one yet. We will add it eventually. But delete is this one right here. All right. And that's what we're going to be moving towards, especially when we get into where we're talking databases. All right. So the classes that are used here, let's look at them. You'll notice there's a product class. Well, that should look familiar because it's the one we already have. All right. And it's got the code, the description, the price. It's got an empty constructor, and that's all that's in there. Okay. And the product DB class and the validator class should look pretty doggone familiar to you. Not this line in. Don't worry about that right now. Is present, is in 32, is decimal, is within range. Well, we could use is present on this one. We could use is present on this one. We could use is present on this one, or we could use is decimal on this one, or we could use is within range on that one. This product DB for now, this is just going to be stuff that we'll go over it, but it may or may not make sense to you right now. All right. As it says here, because you don't really need to know how the product DB class works, the code isn't shown in this chapter. When we get into chapter 17, we'll start going over that because that's what's saving it into a file. I will tell you, you know, you might say, yeah, you got to say that. Okay, fine. But for those people who are listening right now, I don't know how much of this is making sense. Maybe very little, maybe most of it. I don't know. You may have to go back and watch the video again, but if you're not going to do that, I would at least strongly recommend that you read the chapter in the book. All right. So it says figures 1211, 1212, and 1213 show the code. All right, not for the product DB class, but for the other two. All right, I'm not going to go through this, but let's look at the code itself. All right, so this right here, this is the forms code right here. See that? Product maintenance form. This is not class code. So this is everything you see when the form comes up. Notice what we're doing. We're creating a list of products, but we're making sure that it's empty. So we are setting it equal to null. We also only want to be able to use this list of products in this particular program. So we're making it private. Then in our form load, we're calling this get products. Just so you know what's happening there. Again, they won't explain it until chapter 17. But just so you know what is happening in there, all right, what is happening is it is going out and it is seeing if you got a file that's, I think it's just called like products.txt or something, in a certain place on your machine. And if you do, it's loading in all the values. All right. And after it loads in all the values, it fills up the list box with those values. All right. And how does it do that? Uses a for each. It makes sure first it clears it out. Then it goes and it grabs everything that's in there with that display text. And remember, with that display text, what it's doing is it's giving the code and then a tab, then it's giving the description and a tab and the price. And then I think the order that they put it is code, price, description. This is the code that's going to run. We're going to have an add button on our form. What is it doing? Well, again, this isn't going to work for us this way. We're going to have to say FRM new product form equals new FRM new product because we're not using version 9 or above. All right. And then we can call this routine from it. If it's not null, meaning, if we didn't leave that stuff null, then we're going to add the product. All right. This is the delete. Notice what they're doing here in the delete. They're saying I equals selected index. If we haven't selected any index, you learn this from what we just covered in chapter 10. If we have no selected index, meaning we have not selected anything in our list box, the selected index will be -1. So if it is -1, this if statement will be false. So we won't do anything. If it's true, what do we want to do? We want to ask them, are you sure you want to delete the product? And then we bring up that dialog box. If they say yes, they want to delete it, they remove it. They save this, so they're saving our product list without that product in it back to the file, and then they're refilling the list box, but now it should have that product missing from it. Exit, they're just using a simple exit statement. So here's the actual, we're still in new product form. All right. So here's getting a new product. And here's saving a product. Notice what they're calling here, if is valid data. It's a lot cleaner than the way it was before. All right, here's our is valid data. We'll eventually, there's no validator showing here. There is no is present, is decimal. Why? Because that's in the class. There it is. There's the validator class. So what we did was we took the is present, is decimal, and is in 32 and is within range, and we put them in a class so that, again, eventually we're able to take these and we are able to put them into a class library and bring them into any program that needs them. We're also defining what a line break is because the system may or may not know what it is. All right. So, more skills for creating classes. All right, just so you know too. Let me, I didn't work on this during the break. I said I was, but I didn't. So I grabbed this chapter 12 folder. This is, you've got this stuff. This is from Book Apps. So this is that class. All right. So let's see once. I want to open it because I want to show you something. And that is what they don't show you in the book. That they won't show you until chapter 17. All right. Now, if you get this message here, it's targeting a version that is not installed. All right. It's because this is set up for version 7 and I'm running version 8. If you get that error message, just go to Project, down to the bottom, go to Properties, and change these 3 things that'll come up in here that say 7, change them to 8. Technically, there's only one you have to change, but I change all of them. 8, 8, 8. So 8, 8, 8. Now I should be able to do a file save all. All right, even if the message is still there, I should be able to close this now and run it. This is exactly what you saw in the book. There they are. So if I come in here and add a new product, all right, and I will add PHP, Murox, PHP / MySQL. Price $55.44. Save it, and there it is. All right. What's cool about this, though, is I'm going to exit now. All right. And I'm going to get out of the program. And I'm going to bring and run the program again. Now, when I run this, notice what's still there. It has persisted because in that class that they're not showing you, I'm going to show it to you right now. All right. And that is the product DB class. That is expecting that on your C drive, you've got a folder called C#, and then a folder in there called files, and then a file in there called products.txt. Let's see if I've got that. So if I go to my C drive, C:, and I'm looking for a folder named C#, there it is. And I'm looking for a folder in there named files, there it is. And I'm looking for a file in there called products.txt, and there it is. And if I open that, okay, you say, wait a minute, this looks like garbage because I opened up the wrong one. So let me try it again. There it is. It's the second one. There's my files. All right. The separator that they're using in here is this pipe sign. Again, you could use a space, you could use a tab, you could use a new line, whatever you want. But what I'm trying to get across to you, the reason I took a second to tell you this, all right, is that we are working with a concept that we're not going over until chapter 17. So for this whole section of the book, meaning chapters 12, 13, 14, 15, and 16, they're just going to magically say, you've got this product DB class and everything in here works. Then in chapter 17, they're going to explain to you exactly what's happening. All right. Okay. So it says the next figure shows you a way that you can do this stuff. Now, notice what they've done in here. Rather than just get and set like we had looked at earlier, now we're saying, hey, before you get it, do you want to validate that it worked? Or when you get it, do you want to validate that it worked? All right. So what this is saying is, in the first case, if there is no code, return NA. Okay, if there is no code, return NA. Otherwise, in this case, if you didn't put in a code, set it to NA. So this is getting NA. This is setting NA. And you'll notice in here, for lack of better words, value is just kind of a magical variable that you have available to you when you're doing set routines. It's whatever you've set. So I'm going to try one more thing here. I'm looking in here just to check here. All right. So when I come in here to check, I'm going to come in and try this. I'm going to run the program again. Okay. There it is. I'm going to add a product and I'm going to leave the code off and I'm going to put in here Murox SQL server and it's $99.99. Click save and it comes back and it says code is a required field. All right. Okay, so I have to put something in here when I'm doing this. So when I'm adding, I do have to put something in there. So I'll put SQL. All right. What if I leave off the description? It says the description is a required field. All right. Okay, so Murox SQL server. What if I leave the price off? Price must be a valid decimal value. Guess what? It's getting all that stuff from the is present. Now, if I do this, again, price must be a valid decimal value. I don't know if they did a range in here or not. Let's see. No, they didn't do, they're not using the is within range. So I can put in a negative value. Well, I don't want that. So I'm going to highlight it and I'm going to click delete. And notice it says, are you sure you want to delete Murox SQL server? So it's giving me the description. If I say no, it stays there. If I say yes, it's gone. Now, it says a variable that's defined at the class level within a class is called a field. If your property simply sets and returns a value, you can use that one that we looked at with the get with a semicolon and the set with a semicolon. If you need to do some work on either one, you do it like this. All right. Also, because I skipped over it on the previous page, the author mentions in here, a class can contain two types of fields, instance variables and static variables. What the heck is the difference? All right. Well, remember when we did that person before? Every person that was in there had a first name. Every person had a last name. Every person had a department. Every person had a salary. Every person had a marital status. All right. Is it possible to have two people with the same information? Sure. Most of the time it won't, but you could. A father and a son, let's say. A mother and a daughter that had the same name type of thing. But those are instance variables. So each time you create a new object, it needs its own instance variables. A static variable is shared by all members of the class. I want to say that again. A static member is shared by all members of the class. All right. And I probably told you this before, but in fact, I won't even go get into it because it's a boring story. But if I wanted a count of each time I created a new person, let's say, or in this case, each time I create a new product, if I want a count of that, I have to make it static, because if I create 5 new products, I want the count for products to be equal to 5. If I didn't make it a static variable, if I made it an instance variable, I'd have 5 counters. Each counter would have a value of 1. But by making it static, there's just one of them that's shared by all instances. All right. Then they talk in here about public properties. Again, am I missing anything going through this? Possibly. I'm not trying to. It is of paramount importance that you go back and read the chapter. All right. Okay. A public property should be declared as the same data type as a private field. They get into the difference between a property and a field. And the bottom line is this: you can do it either way. All right. It says the main reason to code a public property that uses a private field is to process it in some way. And what they're getting to is this: if you want to be able to do some manipulation with it. All right. Now, please have it in your mind. We're just learning this stuff. We're about to go into our third hour of it. If it doesn't totally make sense, that's to be expected. That's why next week we will do those two problems from the extra exercises together on Monday. Let's say we finish them all on Monday. Great. And we got a little time left. Then we'll do one of the homework problems together. Then on Tuesday, we'll do two more of the homework problems together. All right. And I will give you some kind of a pretest. I may have one written already. I don't know. And we'll go over that on Wednesday. I can't think of another way to prepare you for this. All right. Hopefully it's going to make some sense. Now, when they talk about a method signature in here and overloading, I've already mentioned this to you. Here we've got an overloaded method. What the heck do you mean, Jeff? All right. Notice in the parentheses here, it says string sep. Everything that's in here, public string get display text, and everything that's here, public string get display text, are exactly the same, but the signatures are different. This one requires a string that you're using as a separator. This one doesn't require anything, so it's just defaulting to a comma and a space. So you can call it either way. If you call it the first way, the separator is a tab. If you call it the second way, the separator, so in between the code and the price and the description, it'll be a comma and a space. All right. You can overload constructors. I've shown you this already. You don't need the word this. If I had called this code with a capital C, if I call this description with a capital D, and if I call this price with a capital P, then I would need the word this. If you call it something else or you use a different case, you don't need the word this. Some programmers always use the word this with a dot, but you don't have to. All right. You can say, when you do this, you can say that the stuff that you're working on in here is required. I want to say that again. You can say that the stuff you're working on is required. There is a required keyword you can use with this. So notice when you say required, all right, that means if you don't put it in, you're going to get an error message. Not the same error message we got. This is a system error message that says required member, all right, product.price must be in the object initializer. All right. This is if you do it this way. All right. We're not going to even worry about that right now. Part of the problem with this, and I struggled with this last night. Yes, when it's at night, I do look at this stuff. And I was rereading the chapter yesterday night, and I thought, there is no way to teach this where this makes sense to everybody. It just doesn't happen. That's why I'm telling you how important it is to read the chapter. You can all learn this, but you'll learn it your own way. All right. And I can't say anything more about it than that. All right, these property patterns, okay, I'm not going to go into this. You can use these if you want. All right, but it's a little bit confusing. And I don't want to confuse you. So what are they doing? They're testing object type. So they're seeing if something is a string or it's a decimal or it's a something else. You can even check to see if it's a product. All right. And there's different ways that you can test with this. I'm not trying to overwhelm you with this stuff. So some of the stuff that's in here, I am not spending a boatload of time on. All right. Purposely. Just because, like I said, I'm trying, my goal in here is not to confuse the heck out of you. I want to say that again. My goal in here is not to confuse the heck out of you. All right. The last thing that's mentioned in the chapter, and we're going to go over this, but we're not going to spend very much time on it, again, is this. All right. And that is talking about records and talking about structures. All right. Notice there's a structure, there's a record, and then there's a combination thereof, which is called a record struct. Now, this may make little sense to you, but I want you to see this. When you use a structure and you pass a structure into something, it's a value type. So you're working with a copy. When you work with a class, it's a reference type. So you're passing in the address. What does that mean? That means that if you are using a structure, if you make changes, they're temporary changes. And if you're using a class and you make changes, they're permanent changes. Now, do you even have to care about this? I want to explain to you why you might want to care about this. All right. And I'll keep it short and sweet. Okay. When I was in your situation and I went to a 2-year school, the languages I learned by and large aren't even being used right now. I learned assembler, which I don't think anybody uses anymore. I learned COBOL, which is a language that's still used a lot, but it's not taught very much. But insurance companies and the like use it quite a bit. And I learned RPG, which isn't even really a language. All right. The reason I'm telling you that is when I went in for my first job that I got, all right, it was as a C programmer, not C sharp, but C. And the guy asked me, he said, "Do you know C?" And I said, "No." I wasn't going to lie to him. And he goes, "Good." And I said, "Why?" And he said, "At the local college, the instructor there is one of our programmers, and he'll teach you how to write C the right way." The reason I'm telling you this is when you worked with C, not C sharp, but C, C had no classes. If you wanted to mimic what we're learning to do in classes here, you used a structure or you used a record. All right. And the author even says here, it's generally considered a good programming practice to only use these when you want to work with simple data types. All right. Much of what you do in here looks like, I mean, this doesn't look that different, except it's public struct instead of public class. All right. You can make read-only ones. We can do that too. All right. But other than that, it doesn't really look different from what I've shown you. All right. So what's the advantage of using it? In this case right here, none. None. All right. That's why I'm not going to spend very much time on this. How to use a structure? Well, then they show that, and there are examples. And guess what? Again, it looks very, very, very much like the way that we did it with classes. the name of it, dot, then the stuff. So it looks pretty much the same. All right. I will tell you, I believe, I don't know. I was not around when they created this language. Nobody asked my opinion, but I believe that the reason that they offer a structured data type and a record data type in C# is because many of the people who are C# programmers started as C programmers. And if they want to be able to keep using structures and records, now they can. All right. Again, that's my opinion, and it could be totally wrong. Okay. Now, a record works much like a structure, but it's a reference type. All right. It says, although records are reference types, equality comparisons don't work the same. And again, I believe the reason that you can use these, notice it's public record, and it's record with a little r. It's class with a little c. And I think it's structure with a little s, as far as I remember. Where is that? Yeah, oh, it's struct. Okay. So again, you're going to find that using these is going to be very similar to the way you use things for classes. All right. There's also, as it says, there's a record struct. All right. It says it works much like a structure. It defines a value type, but it's got a better equality comparison. Do you need to care? No. So they update the product maintenance app to use a record instead of a class. So I already showed you the one. It's up already on mine. Here it is with a record. So let's bring that one up. And again, it's going to give me that same message. So project, properties, I'm going to change all these again. If you don't do it and you try to run it, you're going to get an error. And it'll ask if you want to download the newest ones. Don't do that. Okay. Just do this. All right. And then I like to do a file save all and close it. And now I'm going to run this. And it's going to look virtually, I believe, identical to what we just did. There it is. It's even got my PHP that I added. It's working with the same file. If I add a product, it looks the same. So if I come in here and I put in, again, like we did before, let's try it at least, SQL or Murox SQL Server 2022, and that'll be $76.54. There it is. All right. And if I'm going to exit from this now, and I'm going to just see if this worked. So I'm going to go back into the other one and run that one. And there's my SQL server that I just put in. So they are sharing the same file. All right. That has nothing to do with classes. I'm just sharing the same file. All right. And if we take a look at this and we go into our product, public class product, I think this is the first one we looked at. Let me get rid of that. Let me close this. I want to open the right one. So this is record. Okay. So now it says public record. All right. And it looks a little bit different. I am not going to give you, I guarantee you, everything that we do in here, other than possibly, like I said, the written test, you will not be dealing with records. You will not be dealing with structs. All right. So before we finish up, we'll be done in a few minutes, but before we do, again, It says in this exercise, we're going to add a class to this and then add code. All right, to the two forms that use the class. All right, it doesn't look like right now we did a whole heck of a lot, but we're going to have a new class named inventory item. Okay, it will have these three properties. It will have this method. It will have two constructors, a no arg constructor and a full arg constructor, where you pass in the item number, you pass in the description, and you pass in the price. All right. Then, as it says, we'll add the code and we'll put in another form in here. All right. Now, what's the new one? Okay. This is actually different than the one. Okay. This is an inventory maintenance app. So rather than working with products, we're working with inventory. So in other words, these right here are going to be the item numbers. These here are going to be the descriptions. And then in parentheses, we're adding the price. But we're going to do something that is relatively the same. So we'll have an add item where we can add new things and put them in right away. So if we click save here, we would add here that particular item number, crepe myrtle or whatever, the crepe myrtle, whatever that is, and the price in parentheses. If we then highlighted that crepe myrtle and click delete, it would come up and say, are you sure you want to delete crepe myrtle? So we will do that one first. I'm going to go back and look at this. I don't even think it might do more harm than good to do 12.2 and go over this record struct. So I probably won't even do that one. All right. The last thing I'm going to show you, I'm going to bring it up just so you can see it. This is what we're going to be working on. So where are you? Let's see. There we are. All right. So there are 6 problems in here. We're going to do 3 of them. I'm picking out the 3. All right. Then we're going to have flashcards where you will have 5 things that will be in a list. So if I put variable here and I have a definition for variable like this, it'll show it on the screen. If I put in something that's not there, so let's say I put in central processing unit and it wasn't in there, and I click definition, it'll come up and say, oh, what term do you want me to define? And then if I put in central processing unit and I click define, or if I come in here, I can put in a definition for it, click add, then it'll be added. The reason I wanted to show you this is this right here is something that you're going to have to learn. All right. And what we have in here, basically, depending on what book you read, it's either a class diagram or it is a UML diagram. I call this one a class diagram. I'm making it nice and big on purpose. There. Whoops. Like that. Okay. It's actually separated here into thirds. All right. Now, who cares? The top third is the name of the class. So we are going to be creating a class called flashcard. Okay. The second group that's in there that's got term and definition, those are going to be your instance variables. So each flashcard will have a term and each flashcard will have a definition. They're both strings. Then the third one are all of the methods. You'll notice in there that the first method is the name of the class. So that is the constructor. These minus signs mean these are both private. These plus signs mean that these are all public. All right. When you have the constructor, you must pass in a string for the term and a string for the definition. What that means is there is no arg constructor in here. When we call get term, it'll get our term. Get definition will get our definition. This is probably one of the ones we'll do together. All right, it's not that difficult. This is another one we're going to do together. This one's much more difficult. We're simulating a bank here. All right, and you'll have to basically log in. The way you will log in is you will enter your account number and you will enter your PIN. So we will create a list of users that will have a first name, a last name, and an account number, a PIN, and a current balance. If you notice in here, that means we're going to create an account class. That account class will have 4 private variables: an account number that's a string, a PIN number that's a string, a name that's a string, and a balance that's a decimal. And you can probably guess the reason for the account number being a string is there's dashes. Why couldn't we have made that an int? It's not that we couldn't have, but the only time you should take variables like that and make them numeric variables is if you're going to be using them in calculations. We're never going to use the account number or the PIN in a calculation. It's like like the same thing for a zip code. All right. And then we're going to have, these are going to be our methods. Notice there's lots of them. This right here, this thing, that is going to be our full arc constructor. In addition, we'll have a get account number. We'll have a get PIN. When will we call those? We'll have to call those after we put these values in here and click login. We'll have to call get account number and get PIN to make sure that we put in a valid account number and a valid PIN that goes with that account number. All right. After we do that, if it matches, we'll have to get the person's name. All right. And then finally, we'll get their balance. But we also have 2 more methods in here. One that will allow us to make a deposit, one that will allow us to make a withdrawal. All right. This program will probably take a good 2 hours to do. I'm just warning you, for lack of better words. All right. We want to make sure when you deposit that you have got a number in there and it's greater than 0. Otherwise, it makes no sense. When you withdraw, it's even more. It's got to be a number. It's got to be greater than 0. And you can only withdraw, let's say that we say in there you have to have $25 in your account at all times. So here, Mr. Smith could technically withdraw $9,975 and still have 25 left. If Mr. Smith were to come in here and try to withdraw $20,000, they should get an error message. It should throw an exception. All right, we're going to hit on all that stuff. So they're explained in here. Then next, hey, look familiar? We're going to go back and redo the game break program that we did in chapter 8, I think it was, but we're going to do it using classes. It'll have one class, a game class, with the name, the publisher, and the price. Then we will have a full arc constructor, a get name, a get publisher, and a get price. You'll notice there's no sets in here. We're just grabbing information. We're not setting any information. Then I'm going to ask you to redo the movies one and redo the movie one that you did, but redo it using classes. And again, you'll have a name class, a director class, and a description class, a full arc constructor, a get name, a get director, and a get description. All right. I'm not sure if we're going to do number 1 or not. Number 1 isn't hard, so I might just have you do it. But the last 2 that are in here are very similar to one another, 5 and 6. This is a job estimate for Harold's Home Services. Every time you request something from Harold's Home Services, notice what we have in here. Public, and it's all caps. What does that mean? It's a constant. So every time you do a job or you request a job from Harold's Home Services, you get a trip fee of $35. Then you'll get a description of what you want to do, the number of hours it'll take to complete it, and what the hourly rate is. For instance, washing windows is $25 an hour. So 25 times 3.5 is going to be, I don't know, something like, $80, let's say. Then you add the $35 to it for your trip fee, and you get $122.50. Okay? Finally, we'll have this one we'll probably do because I'm actually doing some of the harder ones with you. This, as it says, is a tile estimate. All right? So writing a GUI application that'll tile a room. All right? And we'll talk about it when we get to it. All right? So it's how many boxes you need, etc. for this. So we'll probably end up doing number 6, number 3, and number 2 together next week. You will be responsible for all 6. All right? But you can watch and code along or go back to it later. You will expect it to be to do 1, 2, 3, 4, 5, and 6, but you will have to do number 1, number 4, and number 5 on your own. All right. Now, this bank one, just so you know, it's not the same thing, but with this bank one, what you may want to do, notice I said may, is go back and what I gave you today in this one, you might want to look at this one. It's the third one down. Explore object-oriented programming with classes and objects. Why? Because they go through a whole example in here with a bank account. It is not identical to the one we will do. But if you wanted to start stretching yourself a little bit and see when you do this, if it makes sense to you, you might want to go through this and see what from here, if anything, you might be able to apply to the one we're going to do. So notice there's a make deposit and a make withdrawal. And if I go down here far enough, notice with the balance, all right, there it is, the make deposit. You can't put in a negative number. If you do, you're throwing this. All right, we're going to try to write this in such a way, I'd like to at least. And I got to go back and probably do some rewrite because this just hit me right now. But my guess is what I'd like to do is set this up so that in here and in here, you can only put numbers. So we don't have to worry about, other than it being blank or negative, we don't have to worry about putting hello in here. All right, I've already got these written. All right, so I'm going to go back and go over them with you. All right, at a minimum then, at a minimum. All right, we may not even have a test next week. I don't know. Let's see where we are a week from today. But you will, for certain, you will get next Friday as a lab day because this stuff is going, these 6 problems will be due on Sunday the 10th. I think what I'll do is when every morning you get these emails from me. You get the morning email before we start. You get the other email after we've been going. All right. I think in this second email that you'll get from me sooner rather than later, a little bit later this morning. All right. I will include in here this homework sheet so you can start taking a look at it. Again, to finish up, please take the time to read the chapter. I would even suggest if you can dedicate a few hours to this, read the chapter, don't bring up the code. You can look at it in the book, but just do that. Then go back and go through it again and look at the code. Again, this thing that I brought up here, this thing, right? Come on, right? Come on, right here, this chapter 12, this product maintenance class. That's the one we'll go over first thing on Monday. We will build that one together. In fact, I'm sorry, this is the one that's in your book already. Product maintenance, that's the one I looked at before. I wouldn't even look at the struct one. but I look at this one, make some changes to it, break it, put it back together again. All right. The only way you're going to really learn this stuff is to sit there and play with it. It's not going to be from watching my lectures. It's not going to be solely from reading the book. It's going to be from a combination of everything. And you'll learn the most by trying something. All right. I think also one of the things I might do next week, because I thought of it earlier. For instance, we did the BMI program. I might go back and rewrite that BMI program using a class, just so you get the idea and you can see again how to go from one to the other. Now, I still have to go back from what we started today with this people thing and fix that. And I'll try to fix that and I'll put that out there. So we'll have both the product maintenance thing out there, all right, and the people thing. All right, you'll have both of them out there. That's all I can think of. Tomorrow again is a lab day. I will be online. All right, so please feel free to email me if you have questions. If you have not turned in yesterday's test, for gosh sakes, please get it in and get it in as soon as possible. Your chapters 9 through 11 homework is due Sunday by midnight. All right, so next Monday morning, when I wake up on Monday morning, I start going through and seeing who's done it and who hasn't done it. All right, questions, feel free to email me. Other than that, tomorrow's lab. So have a nice weekend. I will talk to you again on Monday. There will be no emails tomorrow. All right. So, because there's no lecture. All right. I'll talk to you Monday. Have a good weekend. Thanks.